Assalamualaikum. We are all from Group DMB1. We'll explain our research about organic rope. So this is my team member. My supervisor name is Puan Surya binti Muhammad Samdin, and my name is Nur Farain binti Nordin. My registration number is 09DMB19F1057. So this is our table of content. The introduction is a rope is a bundle of flexible fibers, twisted or braided together to increase its overall length and tensile strength. The use of ropes for hunting, lifting, and climbing dates back to prehistoric times. Ropes were originally made by hand using natural fibers. Modern ropes are made by machine and utilize many newer synthetic materials to give them improved strength. More than half of the rope manufactured today is used in the fishing and maritime industry, from Barbara Mary 1987. The problem statement is the jute rope available in the market now have some drawbacks. Among the weaknesses that can be identified is the low resistance to heat exposure, low tensile strength, and low melting point when compared to other composite ropes. This is from Matt Apple Hussein 2020. Next, the dumping of unused organic waste adds to the cost of daily waste disposal. This is also from J. Srinivasan 2012. There are various types of fasteners available in the market that use synthetic materials as the main source, which require a relatively long period of time to be disposed of. So the objective for our organic rope is to investigate the properties of organic rope as compared to conventional jute rope. So the next slide I hand over to my friend Sharul Afizi.
Hi, Assalamualaikum. My name is Sharul Afizi bin Solimin. So now I want to present about the scope. Okay. First, 30 cm long fiber is used to make 8 mm diameter rope with spiral coil. It will be treated with 15 gram of sodium carbonate and coated with epoxy resin at the outer protector. Okay. Second, the sample made from organic material, which is pineapple leaf and banana stalk fiber, will undergo a series of testing against a conventional jute rope. Okay, for the mechanical testing we do is tensile test, density test, fire resistance test, water exhaustion test. Okay, next. For methodology, fiber preparation. Pineapple leaf fiber was taken in the village of Parit Sikom, Air Baloi, Pontian, Johor, while banana trunk were taken in Kota Tinggi, Johor, and sugarcane skin was taken in Kulai, Johor. All of the fiber was taken from the crop farm for sustainable resource. Pineapple leaf will be taken on the side of the leaf that has torn. The leaf will be ripped manually to reveal the fiber found on the leaf using metal plate. Banana trunk fiber are taken from the banana frond and has been cut into pieces in 2 cm widths. Besides, the sugarcane skin fiber also has been taken from the cut of the sugarcane skin according to size of 3 cm width. After that, the fiber were dried in the sun for 5 to 7 days for the purpose of drying. The fiber will separate one by one according to the specific size. The length for the sample is 30 cm. Okay, next for the chemical treatment. The chemical treatment that is performed on the fiber by a water soaking process. The chemical used is sodium carbonate. The NaCO3 is used within 25 gram for 5 liter distilled water for soaking process. The chemical treatment is held in 12 hours. After the soaking process, is done, the fiber will be dried in the sun for 5 minutes before being rolled into rope. Okay, for sampling process, the fiber roll into a rope shape with a spiral roll type. This roll used to strand of fiber. This sample will produce 8 mm fiber rope. This fiber rope is rolled using a rope spinner. We produce 4 different samples, namely sugarcane sample and pineapple fiber sample combined with the banana trunk sample. At the end of this sampling, we have dipped the same with epoxy resin in one layer as a rope protector. Okay, next, methodology. Methodology about the test we do. And this is the material we use to make a rope. Okay, 4 samples were prepared according to the standard for several tests. For tensile tests, we went to a factory to run tensile tests on our fiber rope. On the test, our fiber cord were stretched to the ASTM D638 standard, and after that, we found data for the fidelity of the fiber cord we test. Okay, for density, on the density test, we fill the jar with water until it's full. When we dip the string into the jar, we find the water overflowing out is the volume for the rod. Next, we perform calculation to obtain the data of the density test result. For fire resistant test, we roast the rope into a barrel at 200 degrees Celsius for 30 minutes. Okay, for the water exhaustion test, for the water exhaustion test, we weighed the mass before and after our fiber rope was immersed in water for 2 hours. Okay, next, for the result tensile test. All samples are tested using the universal testing machine. This test is held based on standard qualification of ASTM D638. The result shows that the sample of banana and pineapple rope had reached the maximum tensile strength compared to the jute rope. The mechanical bonding between the banana trunk and pineapple are strong because the mechanical property of fiber had become alloying element to each other. So this is the data we had for the tensile test using our organic rope. Okay, next, for density. Solid density for distillation is measured to determine the composition of the solid rope. In this research, the density of the solid rope for all samples is constant. Besides, all the samples have 8 mm diameter and 30 cm length. The volume of an irregular shaped solid can be measured by submersion in the liquid, so that the volume of this rope is determined by submersion in a liquid. The calculation show that banana and pineapple rope has the high density rate. It is happen because of the combination of 2 samples as alloying element. Okay, this is the calculation data for density for the organic rope. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wafir Hekal bin Muhammad Azhar, and I will be continuing the presentation by talking about the fire resistant test. Fire resistant test is conducted to observe the structure of mechanical properties of the sample compared to the jute rope. This test is held based on standard operation of ASTM E119. The ignition of material due to hot surfaces has been reviewed by Schwartz and Lai and Babrauskas. Ignition was characterized as either visible glowing or flaming. The data shown that pineapple fiber rope has fire resistant rate because of the strength from the combination of many strands of fiber into a rope with solid rolls. As you can see here, there is the data that we have acquired. Moving on is the water absorption test. Absorption is the ability of a material to absorb liquids. The greater the water content absorbed, the easier material can be damaged. This test is held based on the standard operation of standard SNI. This data shows that jute rope has a high water absorption rate. That means it is very easier to be damaged. The sample with the lowest water absorption rate is banana and pineapple rope because of the coating of the epoxy. Okay, next is the project cost. These are our total project cost. To finish the product, we use around 126 ringgit for the material and the equipment. Okay, moving on is the benefits. For the benefits, our product is very eco-friendly as it can be able to compete with the commercial rope. The second benefit is to be able to reduce the abundant agricultural waste by recycling the pineapple leaf and banana trunk. The third benefit is it's very cost effective and not costing very much money to make. Our market potential will be focusing on the fishermen and contractor. Next is the conclusion. The investigation has found out the potential of wet plant fiber compared to the commercial rope with compromised similar efficiency in the industry. In addition, the weakness of the organic rope mechanical properties can be modified with chemical treatment. Through all of the research that we do, we had concluded that banana with combination of pineapple rope has the best result of the strength among the other sample. Besides, it can also compete with the jute rope that is already on the market. I think that's all from me. Thank you for listening.
Assalamualaikum, my name is Aisyah from Intibizidi. I am from DMB1. My metric number is 09 DMB19F1047. I'm going to show you about our final sample. This is the original sample that we take. This is the jute rope. And the second sample is pineapple fiber rope. This is pineapple fiber rope that we had coat it with wax and epoxy. And this is pineapple mixed with banana fiber. We make it rope with the same diameter. This is the banana trunk rope that we make from banana trunk, and the last one is this is a sugar cane rope. It made from sugar cane, and we had coat it with epoxy. As you know that all of our sample has been coated with epoxy. Ini merupakan alat pemintal tali yang kami hasilkan untuk kami siapkan sampel kami dan pintalkan dekat sini. Hari ini saya akan tunjukkan simulasi bagaimana saya pintalkan tali. Ini adalah serat tali fiber nenas. Saya akan pintalkan dan kita akan pintalkan menggunakan gulungan secara piring. Pintalan akan dilakukan secara berterusan sampai tali mencapai kepada tahap kemampatan yang maksimum. Setelah selesai tali dah sampai tahap maksimum, kita akan buka dan ikat hujung dia untuk pastikan ikatan tersebut tidak terurai. Itu saja. Terima kasih. This is the prototype for our rolling machine for the rope. We use it to roll our rope and sampling process. It is made from wood. This is water absorption test. I soak it in distilled water in 1 hour, and then I calculate initial mass with final mass, and then I calculate the average mass.